There is a weapon flying over Ukraine right now that no jammer on Earth can touch. It's secret, a thread of glass, thinner than a fishing line, 40 kilometers long. This is the fiber-optic drone, a flying bomb on a wire. Today, what these drones really are, exactly how the wire works, how deadly they've become, and who builds them by the million. The Pentagon says drones now cause most of this year's casualties in this war, and the fiber-optic drones in Ukraine are the ones nobody can switch off. The technology at their heart, invented in America, the Secretary of Defense admits it himself in writing. So why do Ukraine and Russia field up to 50,000 of these every month, while America's best factory builds 1,000? Stay to the end. Whoever answers that question wins the next war. And America has come from behind before. Strip away the headlines, and the word drone hides more than it explains. So let's get precise. A drone is an aircraft with nobody on board. That's the whole definition. But over Ukraine, that single word covers 4 very different machines. Each one plays its own position on the battlefield. Learn the 4, and the entire war snaps into focus. We take apart one piece of military engineering like this every day. Subscribe so you don't miss the next one. First, the eyes. Small reconnaissance quadcopters that hang over the front lines and simply watch. They find targets. They correct artillery fire, round by round. They follow every vehicle that moves. Most of them never carry a weapon, but almost nothing on that battlefield moves without one of them seeing it first. Second, the deep strikers, long-range one-way attack drones like Russia's Shahid types, propeller-driven flying bombs, programmed before launch, sent in waves against cities and power grids hundreds of kilometers away. Each one costs somewhere between $20,000 and $70,000. Think of them as cruise missiles for the budget-conscious. Third, the weapon that changed everything, the FPV. FPV stands for first-person view. Picture a racing quadcopter about the size of a dinner plate with a camera on its nose. The pilot wears video goggles, and he sees exactly what the drone sees. He flies it as if he were sitting inside it, through a doorway, down a trench line, into the engine deck of a moving vehicle. Now strap an explosive charge onto that frame. The racing toy becomes a guided weapon. Total cost, between $200 and $1,000. Almost every component comes straight from the hobby market. The motors were designed for racing, the camera for sports footage. Only the warhead is military, and the scale of what these machines now do is hard to overstate. America's own Secretary of Defense put it in writing. Drones are, in his words, the biggest battlefield innovation in a generation. And they account, he wrote, for most of this year's casualties in Ukraine. Most. More than artillery. More than anything else on the field. Which brings us to the 4th machine, the newest branch of the family tree, and the reason for this video, the fiber-optic drone, an FPV that has given up radio entirely, and instead flies tethered to its pilot by a strand of glass thinner than a fishing line. To understand why anyone would put a wire on an aircraft in the 21st century, you first need to see the invisible war, not the war of the drones, the war against them. Every radio drone lives and dies by 2 invisible threads. Thread 1, the control link. The pilot's commands, riding a radio signal from his transmitter up to the drone. Thread 2, the video link. The camera's feed, streaming back down to his goggles. Cut either thread, and the drone is finished. Blind or deaf or both. Electronic warfare, EW, is the science of cutting those threads. A jammer doesn't shoot anything down. It shouts, it floods the drone's radio frequencies with noise until the whisper of the real signal drowns in the roar. The pilot's goggles dissolve into static, and somewhere past the tree line his drone drifts, stalls, and drops into a field. So both armies saturated the front with jammers. They bolted them onto tanks, they mounted them on trucks, they planted them along the trenches like fence posts, and a duel began. Drone builders hopped to new frequencies, and the jammers followed. Builders installed smarter radios, and the EW crews widened the noise. Every few weeks, the advantage flipped sides, and the stakes of that duel were absolute. A jammed drone isn't damaged, it is simply gone, along with its warhead and its mission. The pilot survives, miles away, but the soldiers who needed that strike wait for a drone that never arrives. The result: the airspace over the front line became the most contested slice of the electromagnetic spectrum on Earth. In the worst sectors, radio drones were dropping faster than crews could launch them. Brilliant engineering, defeated not by armor or bullets, but by noise. Then, in the spring of 2024, Russian units began flying something different. Ukrainian jamming crews did everything right. They flooded every frequency. And the drones kept coming. They didn't drift. They didn't stall. They flew straight through the loudest electronic noise on the planet, as if it wasn't there, because for these drones, it wasn't there. There was no radio signal to jam. There was only a wire. Here's the machine, piece by piece. Start with a standard FPV quadcopter, 4 motors, a battery, a camera, a warhead. Now delete the radio antennas. In their place, bolt on a canister about the size of a coffee can. Inside that canister sits a spool wound with kilometers of optical fiber, a glass thread not much thicker than a human hair. One end of the thread stays with the pilot. The other end is the drone. As it flies, the spool pays out line behind it, like a fishing reel running in reverse. The thread drapes over trees, across fields, along the ground, and it keeps working. Down that glass travel pulses of light. The pilot's commands ride up. The camera's video streams down. Nothing is broadcast. Nothing touches the airwaves. So there is nothing to jam. The physics is the same trick that carries the internet under the oceans. Light, fired down a glass core, bounces along inside the strand for kilometers with almost no loss. Your video calls ride threads exactly like this one every day. Ukraine and Russia just taught them to fly. Katerina Bonda, an analyst who studies this war for a leading Washington think tank, put it bluntly. The quality of this connection is actually way better than radio or wireless. No static, no dropped frames, crystal clear video all the way to impact. A radio drone's picture degrades as the jamming thickens. The wired drone's picture never flickers at all, and the reach keeps growing. Ukrainian units like the famous Birds of Magyar fly fiber-optic drones out to roughly 40 kilometers. That is 25 miles of glass thread unspooled across the battlefield in a single flight. Manufacturers now claim systems that reach 50. On the Russian side, the Prince Vandal drone designation KVN-35 carries a 3-kilogram warhead out to 35 kilometers. Modernized versions are claimed at up to 65. The thread itself is astonishingly cheap. A 10-kilometer spool runs around $500. $500 to make a weapon immune to every jammer ever built. But the wire takes its tax. The spool is heavy, so the drone gives up warhead weight or battery life to carry it. The thread can snag hard on a tree line or shear against rubble, and the drone dies wherever it hangs. And every mission spends its spool. The line is never reeled back in. After heavy fighting, Ukrainian farmland lies littered with glass filament, glittering across the fields like spider silk. Now, here's the detail that should sound familiar to every engineer watching. Guiding a weapon down a wire is not new. American anti-tank missiles trailed guidance wires all the way back in the 1970s. The idea is old. What's new is the scale and the humility. The breakthrough wasn't inventing something clever. It was accepting that in a jammed sky, the old, dumb physical connection beats the brilliant wireless one. Sometimes the way forward is backwards. Theory is cheap. So let's look at what fiber-optic drones did in combat in the one campaign that proved them. August 2024. Ukrainian forces punch across the border into Russia's Kursk region, seize ground and dig in. It is a stunning raid, and it holds for months. But Kursk is about to become something else entirely. The proving ground for Russia's newest weapon. Russia was the first to field fiber-optic drones at scale, and it concentrated them here. The drones didn't go hunting tanks at first. They watched roads. Every supply route feeding the Ukrainian salient, the pocket of captured ground, watched, around the clock, by drones no jammer could touch. Trucks hauling ammunition, armored personnel carriers rotating soldiers, resupply runs after dark. One by one, the drones on wires found them, and every driver on those roads understood the worst part. Jamming could not protect him. The electronic shields that guarded convoys everywhere else on the front were useless here. All routes were being watched, including the ones the medics used. A Ukrainian medic who served there described it in a single devastating sentence. Our logistics just collapsed. Fiber-optic drones were monitoring all routes, leaving no way to deliver ammunition or provisions. Think about what that means. No breakthrough, no great battle. An army being slowly strangled, cut off from ammunition, batteries, and food by a thread of glass too thin to see. Analysts at the Atlantic Council credit fiber-optic drones with helping push vehicle losses in Kursk to a 25% ratio in Russia's favor, an imbalance unmatched anywhere else on the front. And among the vehicles lost, American-made Abrams tanks and Bradley fighting vehicles, armor worth millions of dollars, traded away against drones flown on fishing line. By March of 2025, Ukrainian forces withdrew from most of the salient, not because they were outfought man for man, because nothing could reach them, and the weapon that did it has a name and a scoreboard. Russia calls it Prince Vandal of Novgorod. Its producer claims 18,900 launches confirmed on video and more than $1.7 billion of Ukrainian equipment destroyed. Treat that figure with care. It comes from the men selling the drone. But even a deeply skeptical reading is grim. One family of wired drones with $1 billion kill sheet. And that's the anchor of this whole story. The deadliest drone of this war is not the most advanced one. It's the one that stopped pretending the airwaves were safe. So the obvious question, if these weapons are that decisive, who is building them, how fast, and what happens to the country that falls behind? This is where the story stops being about Ukraine and starts being about America. Because here is the truth, every engineer in this story already understands. The fiber-optic drone is not a technological miracle, it is a manufacturing one. This arms race isn't won by whoever designs the best drone, it's won by whoever builds the most. Start with Ukraine. In 2024, the country produced roughly 2 million drones. In 2025, production climbed toward 4 million, with officials projecting 5. And Kyiv says that with full funding, its industry could build 20 million drones a year. 20 million. From a nation at war, under nightly bombardment, the fiber-optic branch grew even faster. By mid-2025, more than 80 different Ukrainian-designed fiber-optic drone systems had been approved for military use. Not 80 drones, 80 separate designs from an expanding base of manufacturers. Ukrainian fiber-optic output now runs between 30 and 50,000 drones every month. The supply chain tells its own story. Early in the war, nearly 100% of Ukraine's drone components came from China. By 2025, that dependency had been cut to 38%. Ukrainian firms learned to build their own motors, frames and electronics under fire. And Europe took notice. The European Union committed €6 billion toward drone production. Now Russia. 4 million drones built in 2024, double Ukraine's output that year. For 2026, Russian planning points to more than 7 million FPV frames and nearly 8 million warheads. That is a pace approaching 20,000 drones every single day. And the fiber-optic spearhead has an address. Veliki Novgorod, an ancient Russian trading city, now home to a production center called Oshkwinik. Its director, Alexei Chadayev, built the Prince Vandal program there. Output climbed from roughly 500 drones a month in August of 2024 to a reported 50,000 a month the following year. One program, 50,000 unjammable drones every month. Though here, honesty demands a caveat. Those Russian numbers come from the program's own director. Western analysts see it very differently. The Council on Foreign Relations puts Russia's entire fiber-optic output at under 5,000 a month, 1/10 of Ukraine's. Somewhere between the seller's boast and the analyst's estimate sits the truth, and that fog is not a footnote. In a production war, hiding your real numbers is a weapon too. Sit with those numbers for a moment. 2 nations locked in a grinding war, each building millions of aircraft a year in workshops and converted factories. Now ask the question this channel exists to ask. Where is America in all this? In 2023, 2 young American engineers studied Ukrainian FPV crews at work up close. What they saw convinced them that the United States had nothing like this and needed it badly. So they founded a company, Nero's Technologies. Their drone is called the Archer. It's an 8-inch FPV that flies more than 20 kilometers carrying a 2-kilogram warhead. It flies day or night in bad weather, and it contains 0 Chinese components. Nero's engineered its own motors and cameras from scratch. That made the Archer the first FPV drone approved on the Pentagon's trusted blue UAS list, and by the standards of American defense contracting, It is radically cheap, an order of magnitude cheaper, Nero says, than the other small drones on that cleared list. In February of 2025, Nero's won a contract to send 6,000 Archers to Ukraine, 1,000 a month. That reportedly made it one of just 2 American FPV makers supplying the fight. The Marine Corps added $17 million for 8,000 more, and the founders think far bigger. Their stated goal is a factory that can build 1 million drones a year. Co-founder Soren Monroe Anderson set the bar for relevance himself in one blunt sentence. If we could not make 5,000 drones per month, we were essentially useless. 5,000 a month just to matter. Remember Russia's single program, claiming 50,000 a month. Then in July of 2025, the Pentagon finally moved. Secretary of Defense Pete Hegseth signed a memo titled Unleashing U.S. Military Drone Dominance. Read the targets, and you can hear the alarm bells behind them. Every Army squad armed with small one-way attack drones by the end of fiscal 2026. An Army order for up to 10,000 FPV-type drones within 12 months at under $2,000 each. A $1 billion 2-year program to buy one-way attack drones by the hundreds of thousands. More than 200,000 autonomous platforms targeted by 2027. And in the next defense budget, $75 billion for drones and drone defense. But the memo's sharpest edge was cultural. For years, the US military classified small drones as durable equipment, inventoried, audited, and gold-plated like helicopters. Hegseth tore that rulebook up. Small drones would now be treated as consumable munitions. Ammunition, you buy them by the crate, and you expect to lose them. That single reclassification did more for American drone production than any invention, and the secretary said the quiet part out loud. Lethality will not be hindered by self-imposed restrictions, especially when it comes to harnessing technologies we invented but were slow to pursue. Technologies we invented, slow to pursue. That is the Secretary of Defense of the United States in writing, now the cold shower. As of June 2026, fewer than 3,000 of the 22,000 drones ordered under these initiatives had actually shipped, and American production of fiber-optic combat drones, the unjammable kind that decided Kursk, essentially none documented. 0. So let's close the loop we opened at the start. Why can the workshops of Ukraine and Russia field tens of thousands of unjammable drones every month, while America's leading drone factory builds 1,000? It isn't talent. By the Pentagon's own admission, the core technologies are ones America invented. It isn't money. $75 billion is now on the table. It's philosophy. For decades, American procurement optimized for the perfect weapon. Ukraine and Russia optimized for the next 100,000 weapons. The fiber-optic drone is what that second philosophy looks like at war. A weapon with no ego. A coffee can, a glass thread, and a warhead built by the tens of thousands, lost without a second thought. Can America catch up? Here's the honest answer. The awakening is real. The memo is signed. The money is moving. A company like Nero's exists precisely because young American engineers saw this coming before the Pentagon did. And history says one thing loudly. No nation on earth has ever matched America once its industry gets angry. Slow to start, impossible to stop. It has happened before. But the avalanche has not started yet. Under 3,000 drones shipped, out of 22,000 ordered, the scoreboard doesn't lie, and right now it reads, behind. The thread of glass over Ukraine is more than a clever trick. It is a warning shot fired at every military that believed expensive and advanced always beats cheap and everywhere. The next great war, the one everyone prays never comes, will open with machines like these. Tens of thousands of them, flown by whichever nation bothered to build them in peacetime. America built the Predators and Reapers that owned the sky for 20 years. The question this war asks is simpler and harder. Can America still build things by the million? That answer gets decided in factories, not speeches, and the clock is already running. If you want the other half of this equation, why a $400 drone beats a $4.5 million tank, that video is on your screen right now. Subscribe, and we'll keep taking the world's most dangerous machines apart, one wire at a time.